Physics paper, section A, 40 marks, section 1. A student has listed following as SI units of acceleration. Which one of them is the correct unit? Now remember, what is acceleration? No. We have to look at this. Unit of acceleration. Yeah. So acceleration, the unit for this is v minus u upon t, means meter per second square, correct? But also we have acceleration in the formula F is equal to m into a, and force is Newton and mass is kg into a. So if I have a, then kg goes that side, means it becomes Newton upon kg. So that will be Newton per kg. Did you understand this? Now which one of them is correct? Meter per second square is correct, and Newton per kg also is correct. Which one of them is correct unit of acceleration? Only one, only two, both 1 and 2, neither of them. It will be C. If I use A as V minus U upon T, then meter per second upon second becomes meter per second square. So both are the correct ones. Okay. Now if you would not have got this on your own, then just give yourself 0. Otherwise you have to mark yourself. The second one, charge of an electron is this. Then the charge on a nucleus of atom of oxygen, atomic number 8, will be. Atomic number 8 in the nucleus will have 8 protons, correct? Now they are saying that the charge on one electron is this, which means charge on thinking step, charge on one proton also will be 1.6 into 10 to the power 19 minus 19 coulomb. And the oxygen has 8 protons inside, so therefore charge in O dash atom will be 8 multiplied by 1.6 into 10 to the power minus 19 coulomb. What did they say? They multiplied. 16 8s 128. So 112.8 into 10 to the power minus 19 coulomb. But they have given you 1.28. So 1.28 means I shift a decimal here, means I divide. So here I multiply. So 10 to the power minus 18 coulomb. So which is the correct one? If you would not have done this on your own, just be honest enough and write over the 0. Okay? And then you have to review and revise this. Okay? Put over there, take care. Alright? Come to train takes 4 hours to travel from Pune to Mumbai and takes 4 hours to return to Pune. Distance between Mumbai to Pune is 200 kilometers. Average velocity. What is average velocity? Your thinking step. Average velocity is, what is it? Total distance upon
total time taken.
So total distance is 200 plus 200. And total time is how much? 4 hours plus 5 hours. That means it is 400 upon 9. Correct? Now what are they saying?
Yes.
Oh, average velocity. What am I doing? This is not average velocity. This is average speed I found, no?
Yes, ma'am.
Because distance I have taken. Means I have taken what? Speed. Average velocity, it's gone. The person has gone from Pune to Mumbai and back again to Pune. Correct?
Yes, ma'am.
Okay, so it becomes very easy to get carried away because of this, huh? Be careful. Sound propagates in air. Which of the following is correct statement? When it propagates in air, the particles of the air, they vibrate like this. So they will have compressions and rarefactions. Okay, so this is the direction of propagation, and the particles will be vibrating parallel. So this is correct. Air particles vibrate direction perpendicular. No, not perpendicular. They are not moving like this. Correct or no? Not this way. They are moving this way. The particles do not vibrate. Rubbish. Then why would sound travel? So this is totally wrong. And they vibrate in random direction? No, they form compressions and rarefactions. So correct option is A. Anybody would have got confused, then you have to give yourself 0. If you would know, you can give yourself that mark. Okay. Gravitational force of attraction between two bodies is F when they are separated at a distance d. Later, when the distance between them is tripled, the force of attraction between them. Now, the gravitational force is the force at a distance. It is inversely proportional to the distance of separation. So, you must mention F1 upon F2 will be equal to, tell me, D1 square upon D2 square or D2 square upon D1 square?
D2 square upon D1 square.
Because it is inversely proportional. Agreed? Okay. Now what are they saying? That the distance is tripled. Means D2 has become 3D and D1 has been D only. So 9D square upon D square. This gets cancelled and what will you get? Correct? So F1 upon F2 is 9 upon 1. That means F2 is gone here and this 9 has come here. So F1 upon 9. What has happened? It has become 1/9 of the original. Can you see how much work they required? Yeah? Now, Earth's magnetic field lines are directed from geographic south to geographic north, directed from geographic north to geographic south. Now remember, your earth will have the poles. This is north pole and this is south pole, but the earth's magnet is going to have its south here and north here, correct? So it will go from north to south, means geographic south to north, correct?
Yes.
Did you understand this? Yes? Okay. When a body starts falling down from height h, then the equation of motion takes the form of blah. Now, it is falling down from height h, means initial velocity is going to be 0. S will be equal to h and A will be equal to g, correct? What is our first equation of motion? V is equal to U plus AT. So it will become, this means 0 plus GT. So V is equal to GT. So this is not the correct one. Alright. What is our second equation? S is equal to UT plus half AT square. Correct? So U is 0. So UT will be 0 and S will become H and plus it will be half GT square. H equal to half GT square. Where is it? Not this. V is equal to 80. No. Isn't this the correct one? Tell me. See here. No, V is a, oh sorry, here this should be T, huh? GT. A becomes G, this should be GT. Okay, so this is the correct one. All right.
Yes, ma'am.
How many electrons pass through cross section if 2 ampere current flows through the conductor in 1 second? Okay, now how many electrons? So current has been given and I is equal to Q upon T, correct? So 2 ampere is equal to Q means N multiplied by charge on 1 electron upon time means 1 second. So N into charge on 1 electron is equal to 2. So N is equal to 2 upon charge on 1 electron, which is 1.6. You have to know this number by heart, okay? You remember this? Don't write the unit. So it will be 2 into 10 upon 16 and this goes up, so 10 to the power 19. 2 ones and 2 eights. Then 2 fives and 2 fours. What am I getting? 1 and 1/4 means 0.25 into 10 to the power 19. Am I getting that anywhere? 1.25. Huh? 18 only they have written. So if you shift this, it will become 12.5 into 10 to the power how much you multiplied. So here you'll divide. Understood? Actually, if you remember that 1 ampere current is going to be 6.25 into, sorry, is 6.25 into 10 to the power 18, then 2 ampere will be double of this. Can you see that? Understood?
Yes,
so if you can remember that 1 ampere current, what is 1 ampere current? See, I is equal to Q upon T, right? So 1 ampere is going to be 1 coulomb upon 1 second, correct? Do you remember that 1 coulomb means this number of electrons? Do you remember that in the textbook?
Yes.
Correct or no? That means 1 ampere current in 1 second means these many electrons, correct? So if it is 2 ampere, then double of that. Okay, so this be the smart way of doing this. If you did not know that, then you have to do like how I showed you earlier. What will this be? Which is this one? Will it always attract magnetic substance, a magnet? Yes.
Yes.
Will it direct north-south?
Yes.
Will it be having repulsive property with like poles? That means
Yes,
all
ma'am.
of the above. Okay, let's look at the 10th one. Object from rest. Now here you will have to work this out. Starting from rest means u equal to 0 with a constant acceleration. So A is 0.25 meter per second square. Travels distance of, so S equal to 32 meter. And they say final velocity is how much? Now VUAS means V square is equal to U square plus 2AS, correct? So 0 square plus 2 into 25 upon 100. into S is 32. 25 ones and fours, 4 ones and 4 eights. So I'm getting here uh, V square is equal to 16. Can you see that? So V is equal to under root, that means 4 meter per second. Device by which resistance can be varied is rheostat. Everybody knows rheostat. The slider moves. Slider is also called as jockey. That moves and it changes the resistance in the circuit, so it changes the current in the circuit. Which waves are higher frequency waves? Are they ultrasonic? Oh, higher frequency. Mechanical waves, electromagnetic waves, elastic waves, and sound waves. How do we go for this? Hmm? No? Is it there in our books? Higher frequency, I thought ultrasound they will talk about, but they have not given that. Now, sound waves are mechanical waves. Electromagnetic, they have uh, this you'll have to check in the textbook. I can't remember the numbers by heart. See, V is equal to F lambda for electromagnetic. So frequency will be equal to V upon lambda. So here also you have different range. Where is the textbook? Did you find in the textbook? Just check quickly. Sound waves are also called as elastic waves. This are linked together, so probably they mean this. Have they written in electromagnetic waves as higher frequency waves? Sound waves. I think electromagnetic will be the correct option. It's not there? No. Is it, did you find this in the textbook?
No, ma'am.
It's not there, no?
But they have written the light waves are transverse electromagnetic
Ma'am,
waves,
it's not there in the
while the sound waves in air are longitudinal mechanical waves.
Sound waves are mechanical waves. They are also elastic waves. And electromagnetic are because of the superimposition of electric field and the magnetic field.
So, electromagnetic waves.
Yes,
No,
ma'am.
electromagnetic waves. Now the thing is that electromagnetic waves have the range from 10 to the power 11 angstrom to zero point 0.1 angstrom. Okay, and this one has the frequency will be over here low and frequency will be over here high. So in electromagnetic also you have which one has got low frequency and high frequency. So I can't say all of them will be high frequency. Put this on hold. I don't know why they have asked this.
Excuse me, ma'am. Ma'am, in the PDF of sound which you sent, over there it's mentioned that electromagnetic waves have high frequency.
In that it is written over there.
Yes, ma'am, in the solved questions part of it.
Yeah, so I was actually with tic-tac-toe. If you just do guessing work, then I can say this, but of course I'm guessing, but exact number I don't know. Now sound waves are mechanical waves, they are also elastic waves. So this and this is linked. So the only one odd is this. So that is how I did. Okay, so in that it is written, no? Our textbook doesn't have it, right?
No, ma'am.
Yeah, thank you. Okay, so it is B. So that was that together with when I gave you the PDF. Good girl. Which of the following statements for G, universal gravitational constant, is correct? Come on, where is gravitational constant? This always becomes a little confusing for many of us. Come on, open that page where there is G. What page it is on? Quickly turn to that page.
Page number 83.
Huh. Is G constant everywhere? Is G 9.8? No, no?
No.
So these two are out. Is this correct?
Yes, ma'am.
Is this the correct one? Correct? Okay. Then we come to the 14th one. Which of the following statements are correct? Compass needle rests in geographic north-south direction when suspended freely is correct. Compass needle rests in any direction when placed at neutral point. Which of the following statements are correct? Compass needle rests in any direction when it is placed at neutral point also is correct. Compass needle rests in any direction other than north-south when placed in the magnetic field of a magnet. Now what is this? Compass needle rests in any direction other than north-south. When it is in magnetic field, it will get influenced by the magnetic field. When it is freely suspended, then north-south. But when it is not suspended freely, means when it is in the magnetic field, it will be in any direction except this. Understanding? So this also is correct. So all the above are correct. So D option. Distance between crest and trough of a transverse wave. Crest and trough. This is the crest, this is the trough. Now crest and trough. From here to here is lambda, correct?
Yes, ma'am.
So from here to here will be half of that, correct or no?
Yes.
So
Yes, ma'am.
lambda by 2. So we have finished with 15 marks of this. Count your marks. Question number 2. A. The velocity of a moving body changes from blah to blah in 10 seconds. What will be the acceleration produced in the body? So the initial velocity, write over the question 2A, and you have to give yourself marks, okay? It is 30 meter per second and V is moving from 30 to, okay, so applying brakes, no? Retardation it will be. In 10 seconds means T is equal to 10 seconds. They are saying A equal to how much? What is the formula connecting V, U, A and T? V is equal to, I'm writing this, okay? Okay, if you want, you can write A equal to V minus U upon T also. Okay, so either this or you can use A is equal to what? V minus U upon T. So V is how much? 5 and minus 30 upon 10. So how much is this? Minus 25 upon 10. So that is minus 2.5 meter per second square, and this is the acceleration. If they had to say retardation, then you would have said retardation is positive 2.5 meter per second square. Okay, this was for 2 mark, writing the formula and getting this and correct unit, and that will be our first answer. So what you would have done on your own, would you have got that mark? Okay, then give yourself marks. In the margin put identify scalars and vectors. Now when they have scalars and vectors, write over there scalar and vector. And temperature does not have direction, so you will have temperature here. Pressure is also scalar, so pressure. Electric current also is scalar, so electric current. And vector, magnetic field is vector quantity. The direction of the magnetic field, if there is a bar magnet, you know that this is north and this is south, then you will have like this, not the magnetic field lines, and the magnetic field at a particular point will be along the tangent at that point to the closed curve. Understanding? So we have 1 2 3 4, so half mark each. Give yourself marks out of 2. Okay, we come to C. Can I go fast? State 2 conclusions drawn from bell jar experiment. So C, right over there, 2 conclusions dash bell jar. EXPT. This is the question you are writing, and then below that write number 1 and number 2. What is the first conclusion? Sound needs material medium will be better. Material medium for its propagation. Now, what is the second conclusion? What is the second conclusion that you can draw from there?
Produced by vibrating body.
You can see the vibrations and you cannot see the sound. We say that sound cannot travel in vacuum. Okay, cannot travel, and needs material medium is actually the same thing. Have you got your textbook? No, no? Yeah. What is the teacher holding your book for? You need to study, right?
She took it to teach it in the class and she forgot to give it back.
What does the book say? Is there another one?
No.
You keep seeing the vibrating bell, but you cannot see, no?
Oh, here it is written, sound produced by vibrating body travels from one place to other through the mechanical vibrations of the particle of a medium in form of waves. Thus, a material medium is required for the propagation of sound. Just that much.
Just that, right?
Yes,
so, which are the 2 conclusions? Vibrating body produces sound. That could be sound. We can write that sound is produced by vibrating body. Vibrating body. And for that, I will say, to prove this point, I will say that in vacuum we see the vibrating bell but cannot hear the sound. Okay, so this would be probably most of us will get 1 mark out of that because they asked for these two.
Yes.
Yeah, let's come to D. CGS unit of velocity. Now CGS unit of velocity, it will be centimeter per second, right? If you write like this, what you will get? 0. What you should write? Centimeter per second. Okay, in your physics test last that I gave you, many of you lost marks because of that only. The unit of momentum, you all wrote kg meter per second, that's it. You have to spell it out. The reduction in magnitude of velocity per second is called what? It will be retardation, no? If the velocity, the reduction of magnitude of velocity per second, didn't understand. See here, it is reduction in velocity per second means like this, understanding, which means what? Meter per second upon second. Did you understand? Which is equal to what? Meter per second square. Now what is this meter per second square? Acceleration, the unit of acceleration, right? So reduction of velocity per second is, if it was increase then acceleration, but reduction means it will be retardation.
Retardation. Yes.
Okay, then we come to E. G is called the universal constant. Explain the statement with 2 points. G, universal constant. Now I think many of you will not know this by heart. So explain and write over there 2 points. And I'll give you this for homework just now. Is that okay? Look in the book and write number 1 and number 2. Learn it up. And don't say, ma'am, you learn it for us. Huh? Differentiate between longitudinal and transverse wave. How it should be done in columns. So what will you write here? Longitudinal wave, and write over there transverse wave. What are they composed of? So the first point I'm writing over here, composition. Okay, so longitudinal waves, they are composed of what? Compressions and rarefactions. And what we'll write over here, composed of, tell me? Crests and troughs. Then the second point, medium in which medium to travel. Now longitudinal waves, this you'll have to consult the book because I don't think all of you know it by heart. Come on, turn the pages because this is the learning work. There is one wave that goes through solids and liquids but not gases. Which one it is? Come on, turn the pages.
Transverse waves can travel through solids and liquids. Can be produced only in solids and on the surface of liquids, but not inside the liquids or in the gases.
And longitudinal?
In all solids, liquids and gases.
So what you'll say, travels in solids, liquids, gases. And here for transverse you write for homework. You understood how it is to be done. Yeah, Presenting the work is good. Now let us come to G. This is for 3 mark. Sound travels with a speed. So V is equal to 330 meter per second in a medium if the wavelength of the sound, wavelength is lambda, is how much? 15 millimeter, means 15 into 10 to the power 3 meter. You have to make sure everything is in SI. Then they say frequency is question mark. So for the frequency, what formula do you use? V is equal to F lambda, correct? So F is equal to what? V upon lambda. What is V? 330 meter per second. How much is lambda? 15 into 10 to the power, oh sorry, this is minus 3, mistake, minus 3 meter. Meter got cancelled, and I'll have 330 into 10 to the power 3 upon 15, and meter got cancelled. I have minus s to the power minus 1 remaining, 15 ones and 15 twos and twos. So I have 22,000 hertz. Okay, and write over the frequency. When you write the answer, it should not have only one word equal to this. Okay, so answer 1. Now, is this wave audible? Tell me. 20 to 20,000 hertz. Is it audible? No.
No, guys, it is not audible.
Not audible. Audible. Okay. And then the third one, they say, give the reason. What you'll say? This is so as audibility range. For who? For humans.
Is 20 hertz to
Is
20,000.
20 hertz to
20,000 hertz.
20,000 hertz. Okay, understood. So 1 mark, and this will be 1 mark. How is it? Good, bad, or ugly? Okay. Number 3A, differentiate between mass and weight based on this. So you will make the 2 columns. And here you have to write the first point. What are they saying? Scalars vector. Scalar vector. So mass is what you'll say? It is a, does it have direction?
No,
it's a scalar quantity. Underline scalar. And what you'll write? It is a
vector quantity.
Because weight has the direction, correct?
Yes, ma'am.
Then we have the second point. What is the second? Device. Device. So mass will be measured with a beam balance, correct? So write over there, measured by beam balance. Beam balance or physical balance. I think the word your textbook is using is physical balance. So use physical balance, which is also called as beam balance. Okay, and this is measured by what?
Weighing machine.
No.
Ma'am.
Spring balance.
Yes, ma'am. Sorry, spring balance.
See, weighing machine for today, day to day, but in the physics textbook, it is the physical balance and the spring balance. Okay?
Yes.
Understand that. So that is for 2 marks. If you write over the physical balance, weighing machine, then you'll get 1.5 mark. Understood? So just give yourself mark according to that.
Yes.
We come to B. Explain the term supersonic. Where is supersonic? Who knows it by heart? What is supersonic? Who doesn't know? Open the textbook.
Ma'am, speed of any object greater than the speed of sound.
So speed greater than speed of sound. Come on, write this down. And give one suitable example for this. What is the example given in the book? I'm sure you all have forgotten.
Ma'am, fighter jets.
What is written in the book? Tell fast.
Yes, ma'am.
Examples.
Concorde, jet planes, and fighter planes.
Okay. So you can say jet planes and write even Concorde. Now Concords have become obsolete, but doesn't matter, just mention it. We come to C part. Read.
A body falls freely from a height along a straight line path. Its motion is said to be
When it is falling freely, what is pulling it towards the earth? Is there any force acting on it?
Gravity.
How much is gravity? What is the value of gravitational acceleration?
9.8 meter per second square.
Correct or no? So acceleration, the force acts on a body. If the force acts on a body, what happens? It acts on a body, it produces acceleration, yes?
Yes, ma'am.
Is this acceleration changing when the body is falling freely? What is this acceleration? How much is it?
9.8 meter per second square.
Does it keep changing?
no.
After 1 second, 9.8, after 2 seconds, it's something else. Does it keep changing or it remains the same?
Remains the same.
So how will you describe this? What is the
Uniform.
motion?
Uniform.
It is accelerated motion. Correct or no? Motion supposed to be accelerated motion, and write over there uniform acceleration. Understood. Now this is the first part. What is the second part? Read.
When equal change in velocity takes place in equal intervals of time, it is called as.
Now remember, equal changes of velocity means v minus u is the same in equal intervals of time. So this is equal and this also is equal. So constantly I will have this upon this will be constant, no?
Yes, ma'am.
That means it will be, acceleration will be constant. Understanding? What is it? It will be uniform acceleration. Equal, this thing. Yeah. Double check from the book whether what I told you and what you all said is correct. Double check. Double checked. Double checked. Which page are you? Which page are you?
I'm on page 84.
Which page is this on? Why are you telling me 84 page? 84 page is not the chapter. Come on, turn the pages. Come on. Double check. What does it say?
Yes, uniform acceleration.
What does it say? Read from the textbook.
If the body is in motion with uniform acceleration, that is equal changes in velocity takes place in equal intervals of time. The velocity time graph is a straight line inclined to the time axis.
And what is the page?
Page number 43.
Page 43. Now can you see it is also talking about graph? So revise that because you all had forgotten. Okay, so this is your home study. Remember to make up your work. We come to D. Define neutral point. Now this is learning work. Learning work. You can write on your own. Yes. And then draw the magnetic field of a magnet. So show the magnetic field of a magnet. Show one magnet like this. Show this is north and this is south. Then you have to make sure that you draw the magnetic field lines like this. Some of you draw it like this. Nobody is going to draw like this. This is rubbish. If you draw like this, you will get a 0. It should look like a butterfly. I told you, no? How it should look like? Butterfly. Understanding? And show north to south. And ending in south. Starting with north. Then you show here. And just one more like this. Understanding? And here show this way and show this way. This way and this way. Understanding?
Yes, ma'am.
And if your teachers say that you have to show it as a dashed line, then just take your eraser and just make it dashed. Good shortcut, no? This is for dashed line?
Yes.
Yes or no?
Yes.
Your teachers don't teach you all these shortcuts?
No.
No,
I
ma'am.
know. You're welcome.
Thank you.
Thank you, ma'am.
Oh, I forgot something. Okay, we come to E. Complete the following conversions. What is the first one? 1 kgf is how much? Approximately means what you'll write? Approximately means they say approximately means 10 Newton. Okay, and 1 gf is equal to how many dynes? 980 dynes it is. So it will be 980. They didn't say approximately. Did you understand?
Yes.
Okay, so that finishes our section A. Okay. Question number 4. Give the full form. So write over there IEA, number 2 LED, and number 3 CFL. How many of these you know without any problem? None of them? CFL is what?
Chlorofluorocarbon.
Huh? Chlorofluoro?
No, nothing.
You don't know, no?
No, ma'am.
Okay, so that becomes your homework. Understanding all this is learning work. We come to the B part. B part, state 3 characteristics. So write over there, characteristics of medium for sound propagation. Now this is learning work, but it is important. So we will look at the page and let us look at number 1. What is the first
The
characteristic?
medium must be elastic.
Okay. Medium. Which page it is on?
Page number 194.
What is the second one?
The medium must have inertia.
Must have inertia.
And should be frictionless. Third one should be frictionless.
And third one? Very good. Must be frictionless. So can you see, if we do not know these by heart, you have to make sure that we learn it up. Okay, and it is for 3 marks. So for this also we got a 0. And for this also we got a 0 unless you knew this by heart. Okay, give yourself marks. So you will come to know which are the points where you have to study. Now for this you will have to show the diagram. So show a vertical line, show 0 and show this. Then show 5 and 10, and at 10 this could be the second line because you have rule page, then -5 and -10, and show it like this. Then you will show 1 2 3 4 5 6 7 8, and they become 10 20 30 going up to 80, and that is in centimeter the distance. And this is your x-axis, this is your y-axis. Right over here displacement in centimeter. Tell me when you finish doing this much. Displacement in centimeter. Done that? Now from 10 you mark this point, take this point and draw this curve. Below 30 mark this point and draw this curve, that is your one wave. Above 50 mark this point, show this, and then below 70 mark this point and show this. Tell me when you're done. Done? Okay. What does the first question say? How many waves are shown in the diagram? One wave, two wave. So what you'll write?
2 waves.
Very good. Then we come to the second one. State the magnitude of wavelength of the given sound wave. Now they are saying magnitude of wavelength. Write over the wavelength. Don't write only this symbol. Now the magnitude will be from here to here. Can you see? Show in your diagram from here to here, this is lambda. Of course you could show even from here to here, this will be lambda, but counting will be from 10 to 50, but here it will be from 0 to 40. So how much is it? Tell me. 40 centimeter. Are you with me?
Yes, ma'am.
Then I come to the third one. What does the third one say? State the magnitude of the amplitude. How much is the amplitude? Show like this, A, like this. And what you'll say, amplitude. How much is the amplitude?
10.
10 what? Meter, centimeter? Now in the fourth part they are saying draw the diagram and label one crest and one trough. So in this thing I will show this as crest and this as trough. They are saying just one of them you mark. Are you with me?
Yes.
Okay. Now, so you mark this. This is the labeled one. Now on the same graph, you can have some more questions. Can I give you some more questions that can be asked?
Yes, ma'am.
Yeah. So although this is for 4 marks, let us see what all questions they can ask. As of now, we have the wavelength, correct? So they will say if the wave velocity equals 20 meter per second. Find the frequency. So what will you write? V equal to 20 meter per second, and wavelength is what? Lambda means how much it is? 40 centimeter, which means if I have here SI meter, so this will be 0.4 meter. Do you agree with that?
Yes.
What is the relation between VF and lambda? So F will be equal to, take lambda that side, V upon lambda. So that will be 20 meter per second upon 0.4 means 4 meter, and 10 goes up here. So 4 ones and 4 fives. How much are we getting frequency as? Meter also got cancelled, and I got 5 per second means what? Hertz. Okay. Then the next question they can ask you is the wave audible?
Yes.
What will you say? The answer will be yes. Correct?
Yes. Because
And next
Because
question
the-
you will say justify. What does the word justify means? Give reason. So what you'll say, since audibility
Is
20 hertz to
Huh.
20,000 hertz.
audibility for humans is what?
20 hertz to 20,000
20 hertz to 20,000 hertz, and 50 hertz lies within it. Are you with me?
Yes.
Okay, so did you understand some more questions that are here?
Yes.
Now they can ask you one more question. Tell me which question they can ask you. After frequency, what they can ask you? Time period? Because frequency and time period are connected, yes?
Yes.
So what you'll say, find time period. What will you write for time period? Tell me. We have time period and frequency. How are they related? Time period is 1 upon F. So that will be equal to, tell me, 1 upon 50.
50.
So 1 upon 5 means 0.2 and upon 10. Did you see how to do this? You can do this mentally also. 1/5 means 0.2. Okay.
Yes.
2/5 means 0.4. 3/5 means 0.6 and 4/5 means 0.8. Okay. So this will be 0.02 what? Seconds. See how I wrote seconds?
Yes.
Am I writing like just small s? If I write 0.02 s, won't it look like 25 here? Tell me.
Yes.
Okay, so remember your small s always has to be like this. So if you write s like that, just make it into running. All right, so did you understand the kind of questions that can be asked? Yeah, how was
Yes,
it? 4-mark question. How many of you would get all 4 in this? So we did not get out of these 10, we got only 4 here, I think, most of you. Hai na? Now let us
Yes,
come to question number 5. Let us come to A. Differentiate between light waves and sound waves based on what type of waves are they. So you will have 3 columns. Here you will say light waves and you will say sound waves. What we will write for the first part? Types of waves. So light waves are which one? Transverse waves. Is it not so? What type of waves they are? Electromagnetic in nature, and here sound waves you can write even mechanical waves. Correct? Understood, no?
Yes.
Types of waves. So this will be your light means electromagnetic waves. And what are these? These are the mechanical waves. Now, why didn't I write transverse and longitudinal waves? I can write over here transverse waves. Okay. I can write transverse waves. But for sound waves, what you'll have to write? Longitudinal in air, right? Go to that page. Sound waves can be only longitudinal, is it? Come on, find the differences. Are they given light and sound waves? Have they given in 2 columns?
No.
They have given as a bhashan, I think.
Yes, ma'am. The light waves are transverse electromagnetic waves, while the sound waves in air are longitudinal mechanical waves. That's all that's
Okay, so I will write over the air. So now I've taken into account mechanical waves also, electromagnetic as well as transverse and longitudinal. Okay, so this is how we have to mention. Now what is the second point they are saying? Speed in vacuum. So the second point, what is it? Speed in vacuum. Now what was the first column? Light, no?
Yes.
And second one, I'm not writing everything. So light, it will be, speed is 3 into 10 to the power 8 meter per second. Can sound travel in vacuum? So it will be 0 meter per second in vacuum. Did you understand?
Yes.
Purposely they kept this as a trick part, because you will just write 330 meter per second, but that is in air. Then we come to the third. What is it? In which type of waveform they travel in air? Okay, so waveform in air. Which waveform does light travel in air? Sound in air will be longitudinal, correct?
Yes.
So this will be transverse. Which type of waveform? See, which type of waves and waveform. So transverse, and I will write in the form of in crests and troughs. And longitudinal means in the form of what? In compressions and what? Rarefactions. You understood what we are saying? Yeah, if the particle of the medium goes perpendicular like this to the direction of propagation, when it reaches the highest height, it is the crest. When it goes to the lowest depth, it is called the trough. But for the mechanical waves, the longitudinal waves, it will be compressions, then rarefactions. Again compressions, then rarefactions. Understanding? Now one compression and one rarefaction is one wave. So they will ask you like this. See here. They will ask you how many waves are there. So they will give you a little more space here, that side, and then they will say from here to here. Okay, let us say from here to here. How many waves do you see? One compression, one rarefaction, one compression, one rarefaction. So this is one wave, and this is another wave. Understanding? So two waves like that. So they can ask you even that way. In the graph, they had given us crests and troughs. Now we come to the B part. They are telling you functions of galvanometer. How many of you know the function? What is the first one? It detects what? Weak current in a circuit. Correct?
Flow, direction flow current.
And then second one, it detects what? Direction of current also. Direction of flow of current. Now I'll just keep this in front of you. Galvanometer looks like this, okay? And we'll write over here G. So this is 0. So it can deflect this side. Then I know that the current is in this direction. If it deflects this side, then I know the current is in the opposite direction. Did you understand?
Yes, ma'am.
Okay. So how it deflects from here to here or from here to here tells me the what? Direction of flow of current. Understood? Understood.
Yes,
Yes,
Second
ma'am.
one. Now NiFe. NiFe accumulator, nickel ion accumulator, is the example of what? Is it primary cell or secondary cell? Do you have primary cell and secondary cell in your textbook? Is it there?
Yes.
Primary cell and secondary cell?
It's a secondary cell.
Isn't it written over there, secondary cell? Yes.
Yes, ma'am.
Where are secondary cells used? Where are they used?
Toys.
Toys and mobile phones.
Secondary cells.
Yes, ma'am.
That accumulator.
No,
Accumulator
it's not
I'll
given
use in the
specific-
huh?
Specific use of
Low.
NiFe is not given.
Low and high current.
No, that's all okay. But for the mobile, I'm going to use accumulator.
As battery in car.
Battery in the car. No, it's similar. So I'm talking about secondary cell, right?
Yes,
It's
it gives
written
high
that much
current.
only. We use
Now,
a
1
number
minute.
of
Secondary cell and primary cells, correct? Where are secondary cells used? In the
In
car
car.
batteries.
Car.
Are they saying secondary cells are in the mobiles also?
No,
No.
low current rechargeable cells are widely used in toys and mobile phones.
But that is the rechargeable battery. Okay, low current. Now, low current one is not the accumulator.
Yes.
When do we use the accumulator?
As
I
battery
know
in
that
car.
I have the inverter over. Okay, so it's got the battery that we use in the car. We're using those, correct or no? Even in the vehicles. Have you
Yes,
seen in the scooter?
Yes,
There is the
ma'am.
battery. That is your secondary cell. Understanding? It gets charged also, discharged also. But if it's a weak current, then I can't use accumulator in that. Am I going to use the car battery for the mobile? Charging and recharging?
No.
No. Yeah, there I need large amount of current. So you must remember the difference. Okay, what do they say? Draw the non-uniform magnetic field lines for the following magnetic field lines due to two unlike poles. So write over there mag field due to. Number 1, write fast. Unlike poles facing. Okay, for that I will show this way. I will show north, and here I'll show south. Will there be attraction or repulsion? Unlike pole.
Attraction.
So what it will be? North to south, and then one like this line, one like this line, understanding? And
Yes,
then you can put one more, but do not let your magnetic field lines touch each other. Understanding? Do not have them showing like this. You understood what I did over here? This will give me 0. Okay, so make sure that they are not touching each other. Then what is the second one? Due to
bar magnet.
Bar magnet. So I'm writing bar magnet. For the bar magnet, I will just show like this. Show one is north and one is south. And I'm going to show like a butterfly like this. Do not show like this semicircle. If you show like this, you'll get a 0. Does this look like a butterfly? No, this looks like a protractor, no? No looking like protractor. Understanding?
Yes.
So we have from north the lines will start and they will end in south, and then in between show this and this, but make sure that they do not touch each other. Then you will show this way and they will show like this. Make sure that they are oval, not like a protractor. Don't let it look like protractor. And the direction is always from north to south. And then if your teacher says dashed lines, so can you see with the eraser what you can do? This is good idea, right?
Yes, ma'am.
Okay, so this is due to bar magnet. But I also wanted you to tell me, supposing they had to ask due to like poles facing. If it is like poles, this becomes like a star question, not there in the textbook. So 2 marks for each. Okay, so let us say this is north here and I am having north here. Then in that case, what I will do, I will make sure that from the center I will get like this, north and north will repel. From somewhere above the center I will show like this. Okay, then from somewhere below the center I will go this way to show repulsion, and somewhere below the central part I will show like this. Okay, then a little additional part over here. Understanding?
Yes, ma'am.
And can you see equal and opposite? So what will I get over here? So what I'll say, x is the,
Neutral point.
yeah, and neutral point, you have to know the definition. It is the point in the field at which what? The magnetic field is equal and opposite. What will happen if you put a compass needle in that neutral point? It will stay in any direction. Why? Because there is no magnetic field. All these are separate questions. I hope you are noting them down as I speak. We come to question 6. 2 points state the importance of law of gravitation. So question number 6, importance of law of gravitation. Which page it is on? Which page it is on? Quickly tell me. Page number?
Page number 84.
84.
82 or 84?
84.
84. Can you read them quickly? Importance.
Newton used this law to explain the motion of planets around the sun, the motion of the moon around the earth, and the motion of a freely falling body.
Okay, so can you see there are 3 points over there? They are
Yes,
asking for any 2 points. So this becomes your homework. All right, we come to the second part. Which of the following relations is true for time period and frequency of the sound wave? So T and F of sound wave. Now you tell me, what is the relation? Isn't it F is equal to 1 upon T? Or I can say T is equal to 1 upon F, correct?
Yes, ma'am.
What are they telling you? First one, time period is reciprocal of frequency. T is equal to 1 upon F is correct. Frequency is reciprocal of time period. Is it correct?
Yes, ma'am.
Product of time period and frequency is
1.
Yes, ma'am.
Yes.
1. Correct
Yes,
or
ma'am.
no?
Yes,
Because if
ma'am.
you cross multiply, what will I get? T into F equal to 1,
One.
correct? Fourth one is all of this is correct. None of this rubbish. So what is the correct one?
All of these.
So it is which one? 4. All of these. So 2 marks here and 1 mark here. Now can you see over here B part? What are they telling you? Differentiate means make the columns. What is the first column? Primary cell. And what is secondary cell? The second one. Which page it is on?
209.
Is it ready-made given over there?
Yes,
Which means you have to learn it up. If you do not know it, learn it up and that becomes your homework. Okay, learn it up and write it. Will you do that?
Yes, ma'am.
Okay. Now what are they telling you first? They are giving you type of chemical reaction. So number 1, number 2 and number 3. Write in the margin. What is the first part? Type of chemical reaction. Now look at the differences. Primary cell, what type of chemical reaction it is?
irreversible.
Area possible means
Irreversible.
irreversible. And what is this here?
Reversible.
Reversible.
So did you write type of chemical reaction? And here under this it will be you wrote these points. And secondary means what? It is reversible, correct?
Yes, ma'am.
The amount of current that it is capable of giving. Write over the amount of current capable of giving. Wrote it. I don't have space, so I'm not writing. But you write here. What did you write here?
Weak current only.
Read current means?
Weak current.
So this will be weak current and here
Low as well as high current.
low as well as
High
High
current.
current.
then resistance they offer.
The internal resistance is high.
For primary cell,
Yes,
for secondaries and auxiliaries.
And here it is
Low.
low. Okay, so remember this, you have to learn the points. All right, then according to the given question you can change the answer.
Yes.
Okay, now they are giving you 3 wires ABC of equal lengths. You will have to show the diagram. This is thicker, this is thinner, but the lengths are the same. So L1 will be L, L2 will be also L, and L3 also is L. In which wire the current is the greatest? So what you'll say? Current greatest. What does that means? That is resistance least. Understanding?
Yes, ma'am.
Now, if all of them have the same length, the area of cross section is going to determine, right?
Yes,
Now,
ma'am.
area of cross section and resistance, how are they connected? More the area of cross section. Look over there. Which page has this? Which page has this?
220.
Right over there, page 220.
The
Okay.
resistance of a wire is indirectly proportional to the cross section of a wire.
Inversely proportional. Means, resistance least, if it will be thinner, correct or no? That is resistance least, therefore least area of cross section. Understanding?
Yes, ma'am.
Write into brackets since R proportional to 1 upon A. Correct or no?
Yes, ma'am.
So therefore, which is the answer?
Rod C.
Rod C. Make sure you underline so that it is spotted by your examiner.
Yes, ma'am.
Explain the answer into above. Oops, I explained already. So second one, you can write this. Okay. Arrow shows the direction of electrons. Where is the arrow? Here. Like this, direction of electrons. So for the third part, state the direction of the current. If the direction of electron is from X to Y, the current will be
Y to X.
So what you'll say, current will be Y to X. Underline that. Then we come to the fourth part. What is the fourth part? Select the high potential at the end X or Y for each wire. Now high potential will be, see, if the current is from Y to X, Y will be higher and X will be lower. The current goes from higher to lower. Electrons go from lower to higher. So in your diagram, right over this is low potential and this will be what? High potential. And right over there, because they have not asked for the reason, what you'll say, since electrons flow from lower to higher. potential. Okay, so what will I write over there? State the higher potential and which one? Y. Correct? Y is higher potential.
Ma'am, could you please explain this part again?
The electrons, see, you understood that the actual current goes like this?
Yes, ma'am.
It will go like this.
Yes,
The
ma'am.
current goes from higher to lower. See, if you have a cell like this, and the key and the resistance and the rheostat like this, okay? So this is positive, this is negative, yes?
Yes, ma'am.
So this will be higher and this will be lower, correct?
Yes, ma'am.
So the current will go like this. Okay, the current will go this way. But the electrons will go like this, opposite direction. Understanding? Electron I am showing with a shaded arrow. So electrons are going from negative to positive, means lower to higher, no? But the current is going from positive to negative, means this is higher to lower. Now understood? No?
Understood, ma'am.
Huh. You're with me?
Yes,
So
ma'am.
now here, understand where you would have goofed up and lost marks. You can give your marks then accordingly. Let us come to question number 7. Our question number 7, what does it say? Read.
With respect to figure given below, a car starts moving from A, rests, and it accelerates uniformly for 10 seconds at the rate of 2 meter per second square. It reaches to location B. For BC, it is moving with constant speed for 200 seconds. At C, brakes are applied to the car and it slows down uniformly and comes to rest at D in 50 seconds. Calculate 1. What is the maximum velocity attained by the car in journey from A to D?
Okay, there are 3 questions, no, based on this?
Yes, ma'am.
Yeah. Okay. You will have to show this. Finish drawing this ABCD.
Yes, ma'am.
Car starts moving from rest. So here U is equal to 0. It accelerates uniformly for 10 seconds at the rate of 2 meter per second square and reaches B. So your acceleration is 2 meter per second square. Okay, and this is time is 10 seconds. Then it's coming to B. For BC, it is moving with constant speed. So from here, constant speed. From here to here, and write for 200 seconds. That is up to C. Then at C, brakes are applied. So here to here, what is going to happen? Retardation, correct? So I'm writing here retardation. And it is for, it comes to rest, means this V is equal to 0, correct? Because it comes to rest and it has taken time equal to how much?
50 seconds.
50 seconds. Okay. Now What is the first question? The first question says maximum velocity attained now. Tell me, maximum velocity, when it is accelerating, it will be maximum velocity, right? So maximum velocity will be at B. Do you agree with that? Max velocity will be here. Now this is constant speed. So here up to here there is max velocity. Understanding?
Yes, ma'am.
And then it is going to show retardation. Understanding? So they are saying what is the maximum velocity. So for that I will using AB. I will have initial velocity equal to 0, A equal to 2 meter per second square, T equal to 10 seconds, and V equal to question mark. Can you see VUAT? Did you find that?
Yes,
Which
ma'am.
relation, which equation of motion I should use?
V equals to U plus
V is equal to U plus AT. Okay, can you substitute and get the answer?
Yes, ma'am.
Equal to below equal to 0 plus A is 2 and T is how much?
10.
10.
So how much is that?
20 meter
20 meter
per second.
per second. So what is the maximum velocity attained? What will you write after this? Therefore max velocity attained from A to D equals how much? 20 meter per second, and put that in a box. Got that? That is your answer 1. Answer 1. Done that?
Yes,
Yes,
ma'am.
ma'am.
Okay.
Retardation in last 50 seconds.
Now we come to the second part. We want retardation in last 50 seconds. So in that I will have to use, what is the initial velocity over here? This is 20. Maximum velocity means here, can you in your diagram write 20 meter per second? And here also maximum velocity at C. Will you write over there 20 meter per second?
Yes, ma'am.
Wrote it?
Yes, ma'am.
So U is equal to 20 meter per second, correct? And V is going to be 0, correct? And time is
50 seconds.
50 seconds. And for retardation, I'll find A equal to how much, no? Again, I'll say what? V is equal to U plus AT. So 0 is equal to 20 plus A into how much? 50.
So 0.
Correct? So how much is that? Minus 20 is equal to 50A. So A is equal to minus 20 upon 50, which is equal to minus 0.4 meter per second square. But then what we will say, therefore retardation
Equals to minus.
Very good. Is equal to what? Minus A, which is minus into bracket minus 0.4 meter per second square. Understanding? That will be 0.4 meter per second square. How's it? You would have done it on your own or no?
Yes,
Yes,
ma'am.
What is the third part?
The distance traveled by the car during retardation.
Distance during, I'm writing CD. Is that okay? So I am writing initial velocity is 20 meter per second, correct? Final velocity is 0 meter per second, correct? A is equal to how much? Minus 0.4 meter per second square, and time is equal to 50 seconds. Now I have to find distance. So which formula should I use? Shall I say ut plus? Shall I use that, or v square minus u square? I think v square minus u square will be faster. V square minus u square is equal to 2as, or you can write v square equal to u square plus 2as. Okay? So v square is how much? 0 square minus 20 square equal to 2 into minus 4 upon 10 multiplied by s. Correct? So 2 ones and 2 fives. So minus 400 is equal to 4 upon 5 with minus sign into s. Now minus and minus got cancelled, and s equal to 400 into 5 upon 4.
500.
Very good. How much is that? 500 meter. And then what you will say? This you'll write distance. Distance during CD. Okay, and that is our answer. How is it? Good, bad, or ugly? Okay, understanding. So we have finished with question number 7. A. Now can you see over here? B part I'll have to give you for homework, no?
Yes, ma'am.
Right over there, 3 properties of mag field line. This is learning work. Leave approximately 4 lines. Okay, this is for 3 marks. Then we come to C. What is the first part? Read.
When can magnitudes of displacement and distance covered by a moving body be equal?
So what you will say? When they are in a straight line, correct? Because displacement means shortest distance in a straight line, correct? So when displacement and distance are in a straight line, then they are equal. Tell me which keywords you will underline.
Straight line.
Equal.
No, they are saying equal in the question. So when they are in a straight line. Understood?
Yes, ma'am.
Okay. Then we come to the second one. Read.
With respect to cell, how do we connect a key in the circuit?
How do we connect the key in circuit? If there is a cell like this, the key is connected like this, correct?
Yes, ma'am.
Now go to the key part of the electricity and see how it is connected. Are they saying it is connected in series? Where is the part of key?
Page number 200.
Page number 2.
11.
Page 211. Did you spot how the plug key is connected? How the key is
The
connected?
key is always connected in the wire connecting the higher potential, that is the positive terminal of the battery.
That's it? They didn't say in series?
No, nothing.
Okay. So we will write over there that the key is connected to higher potential of the cell, into bracket the positive terminal. Now for your information, show this diagram. This taller line means positive, shorter line means negative. So can you see key is connected to the positive? Okay.
Yes, ma'am.
Yes, ma'am.
Come to the third one. Conventionally, in which direction the current will be negative? Now conventionally the current is supposed to be from higher to lower, correct? But the current will be negative, will be from lower to higher. Actually current is never negative. Current is negative from lower potential to higher potential. Okay, lower to higher. At blah, the magnetic field is stronger. That means they are talking about the poles or the equator. Now this is a little dubious question because they didn't talk about the Earth's magnetic field. So if we are talking about the normal magnet, then there will be many lines over here. So this part will be magnetic field stronger. This also will be magnetic field stronger. And here in between will be weaker, right? So what we will say at poles. And if you wish to show the diagram, then you can show this is north and this is south. So there will be many lines like this, like this. Can you see that?
Yes, ma'am.
Okay, so what you will say? More mag field lines, therefore stronger field. Understood?
Yes,
Okay.
ma'am.
Did we understand how to think? Now
Yes,
is this the question number 8, last question?
Yes.
Yes. Can we just finish it off?
Yes, ma'am.
Yes, we can finish it off. Read.
State the correct location of neutral points in the following cases. 1. If north pole of a magnet faces towards geographical north, and if south pole of a magnet faces towards geographical north.
Okay. So question number 8A. Neutral points. And number 1, when north of magnet faces geographic north. Okay. Does that mean NN?
NN. So
Look
Yeah.
at the diagram. Which page number it is?
Page 230.
Page 230. Where is page 230? Which one it is? Where is neutral point? East, west?
East, west.
Yeah. Is it NNEW?
Or no, ma'am. NNSS, then neutral point will
Aha.
be
Okay.
WE.
So NNSS will be EW, correct? Understanding?
Yes, ma'am.
So what will I write over here? Location of neutral points you have written. So what will I write as the answer? Neutral points on east and west, correct? Correct?
Yes, ma'am.
Now what are they telling you for the second one? What was the mnemonic? NS, 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 correct?
Yes, ma'am.
Is it making sense to you? All of you tell me. Yeah?
Yes, ma'am.
So what will you write for the second one?
Neutral points on north and south.
South of magnet faces geographic north. Okay, which means what I told you, NS, NS, NS. This is the mnemonic, correct? The earlier part, what did I tell you? NNSSEW. Okay, so what you will say, neutral points at north and south. Okay, let us come to the B part. What are they saying?
There are no positive and negative terminals on a galvanometer, but they are present on an ammeter. Give reason for this statement.
So what will you say? See, galvanometer shows the direction of the current. So it cannot have positive and negative. Correct? So what you'll say? Galvanometer detects the current and its direction. As the direction of current is not known in advance, correct? Not known in advance. It does not have positive or negative terminals. Understood this part?
Yes, ma'am.
In the next paragraph, what will you write? Tell me.
Ammeter.
Ammeter measures the current in circuit which has current flowing in a particular direction. Hence, it will have what? positive and negative terminals on it. Understood, no? Because already we know from where the current is going. So from where the current is going, then we know that is the positive part. Understanding. Let us come to the last question. No, second last question. What does it say, read?
A stone is dropped from a tower 320 meters high into a pool of water at the base of the tower. What is the time interval for the splash of water to be heard at the top of the tower after the stone is dropped? Take g as 10 meter per second square, speed of sound and air as 320 meter per second.
So if we show the diagram, the stone is dropped from here, correct? So I'm just showing this is the tower. From a tower, from here to here, it is 320 meter per second. Okay, and this is the pool of water. At the base of the tower. What is the time interval for the splash of the water to be heard at the, okay, so time for splash of water to be heard after stone is dropped. So let us call this part as A and this as B. Okay. So I don't need this. I thought it was going to the base of the pool. So I put all this. So we don't need that. They are giving you G equal to 10 meter per second square and speed of sound in air is 320 meter per second. Agreeable to you? Okay. Now, remember the stone is dropped. So, for motion A to B, initial velocity is going to be how much? 0. Correct? G is going to be equal to 10 meter per second square. And the distance is going to be S, how much? 320 meters. Correct? So I'll have to find out in how much time it is reaching there. So I must find out T equal to how much. Now S U G T means S is equal to UT plus half AT square means I'll write GT square. Are you with me so far?
Yes,
So 320 is equal to, come on, 0 into T plus half into 10 into T square. How much would that give me? 320 is equal to 0 plus 5T square. Correct? So T square will be equal to 320 upon 5. 5 ones, 5 sixes, 5 fours. So T is equal to 8 seconds, yes? Okay. So if I started the stopwatch when I dropped it, it took 8 seconds to reach B. Understanding? Now it went splash and the sound is traveling from B to A. Okay. Now I'm going to say for sound to travel from B to A. excuse me, distance is equal to 320 meters and the velocity of sound is 320
Meter per second.
Therefore, time will be equal to, now your velocity is distance upon time. So time will be distance upon, correct, which is equal to 320 meter upon 320 meter per second.
So 1 second.
So time is 1 second. Therefore, the time for splash to be heard
Is 1 second.
after stone dropped is equal to this initial one I'll call as T1 and this I'll call as T2. So 8 seconds for the stone to fall and 1 second. Did you understand? Did you understand?
Yes.
1 second for the sound to. Okay, now let us see D. This is time pass. First few magnets were pieces of what? Lodestone, no? Which is the ore? Ore of this means what? Iron is the ore of Fe3O4. Was
Yes.
it lodestone?
Yes.
Yes, ma'am.
What is the spelling of lodestone?
LODESTON.
The second one. Explain the directive property of the magnet. What you'll say when it is freely suspended? Magnet. How does it rest? Rests in which direction? North-south direction. So this is made use of in compasses. Then the third one, induced magnetism. Induced magnetism is again something that you can learn up and write for homework. Now from here, whichever part you have to learn up, you have to learn up. Okay, can you see this was a good application question? Can you see that? We have not seen a question like this in the textbook, right? Yeah, so remember these are some of the questions. So which ones you found a little challenging, you have to revise those. All right, so we have finished this paper.